Hi, I'm Mr. G, sometimes addressed as Dr. Bruce the Science Moose. My program is entitled Literacy-Based Teaching of the Scientific Method. I integrate reading, writing, and math activities while framing my lessons around the scientific method. The carrot at the end is a 15 to 20 minute hands-on experiment the kids perform. I was a second grade teacher for 15 years and have been doing my science program for 20 years. It's important to note that I'm a teacher first, a scientist second, and therefore I don't have any issues with classroom management, and I'm very sensitive to the students' needs. At our yearly open house, I told my group of parents that my ultimate goal was to be the one teacher students remembered as really affecting their educational experience. I think I've achieved that multiple times. Now I teach 2,200 kids, K through 4, in 5 schools. It's a lot of names to remember. It's really important to personalize things and address the kids by their names. I have my memory tricks allowing me to do this. My biggest reward is when the kindergartner comes up to me and says, "I want to be a scientist when I grow up." You guys have a good recess?
Yeah.
Okay. Okay, you guys can get seated so we can get started, guys. You know how a lot of my experiments seem like magic?
Yeah.
Okay, here's the big difference. In magic, you have no idea how it happens. It's just magic. But in science, even though it looks like magic, you can explain why it happens with your science ideas. That's a big difference between science and magic. First, we review the scientific method with definitions for each step. Then I call on different students to read one sentence at a time from the lab sheet. I'm very careful with the vocabulary to encourage reading fluency. So, everybody, what do I write on the board?
Scientific method.
Good. Find it on your lab sheet and circle it. I am checking. Remember, copy off your friends if you don't know where it is, because I like you copying, not like other teachers. Okay? So, 5 steps to the scientific method. My favorite science word in the whole world. I hope this is stuck in your brain since kindergarten. Don't call out. Raise your hand. Okay, when I say 3, the kids that know these great science words will say out loud. 1, 2, 3. Yeah. I heard everybody say hypothesis. Let's clap it.
Hypothesis.
How many?
4.
4. Okay, anybody remember what it means? Big hint. Guys, remember when we do this ABCD part? What are we doing when we do that part? Raise your hand. Owen.
Voting.
Voting. Aren't we guessing what's going to happen in our experiment? Are we, guys? Yeah, so that's a hypothesis. When you try to guess what's going to happen before you do your experiment. Okay, last step. Raise your hand if you can read or remember that word. Cooper? She's got it. Conclusion. Let's say it.
Conclusion.
Okay, let's clap it.
Conclusion.
How many? 3. Anybody remember what it means? Conclusion. Conclusion, Carson. Yeah, exactly. We tell everybody what happened at the end of the experiment. Take note of my lab coat. It's important to dress in character, transforming your classroom into a laboratory. Think of this as putting on a show. You're performing, and in a good performance, there are no dead spots. Keep things moving and engage the kids as often as possible. Throwing the lab sheets allows for some controlled chaos, which is fun for me, but more importantly, fun for the kids. Okay, guys, get a lab sheet! I got extras up here. Come on.
I got it.
Okay, I got extra lab sheets here. Get your name on your lab sheet right away. And we will get started. The students are then tasked with a reading comprehension activity, circling the materials we need and composing a corresponding list of them. I review the way the experiment is to be set up, presenting a visual representation. Okay guys, 8 things. That's a lot of stuff. Go on your word search, find those things, circle them. You can work with your neighbors. You might need help. It's not a bad idea to consult with your neighbors if you don't know where something is, because there's going to be some hard things to find. Okay, so I have these plates. I'm going to just sort of tilt it so you guys can see what's going on. We have these 2 pennies, and here's what's really important. This cup has to sit on these 2 pennies. That's really important in the experiment. Everybody see this? Okay, do you see how it's in the middle of those pennies? Okay, and I don't want a cup like where the pennies are on the very, very edge, or I don't want the cup so a penny's inside of it. It has to be sitting on the 2 pennies like that. Then a candle's going to go in the middle. Now, we're going to have colored water, food coloring with colored water. It's going to cover the pennies. Okay, just barely cover the pennies, okay? So we'll have colored water on the plate, covering the pennies. The candle's going to be in the middle like this. Okay, everybody see the way it's set up? Okay, so here's what happens. At the very end, I'm going to light everybody's candle. And then someone's going to take the cup and put it right on top of the pennies over the candle. And we want to know what happens to the water when we do that. You guys understand the experiment?
Yes.
Okay, so now we have to make our hypothesis and try to figure out what's going on. So, your choices. Choice A says the mixture will bubble up and the water on the dish will bubble over, okay? B, the water on the dish will disappear. C, the water on the dish will be sucked into the cup. And D, the water on the dish will become totally clear. Okay, guys, I'm going to repeat those and I will give you your predictors. Now, you guys are going to be careful of those pins, right? Okay, because we did it last time. Okay, so A, the water on the dish bubbles over the plate. B, the water on the dish will disappear. C, the water on the dish will get sucked into the cup. And D, the water on the dish becomes clear. Okay, everybody know what they're voting for? Okay, now guys, don't discuss it with each other because I want everybody thinking for themselves. Give everybody a predictor here. The students then read the 4 different choices or hypotheses aloud and choose the one they think is right. I give them predictors to post on a corkboard chart. I then ask appropriate level math problems relating to the results of the voting. I'm going to put the prediction chart here, and if you are wearing orange, you are the first one to come up. Come on up. Orange anywhere. If you are wearing green, burgundy, that might be orange. No, that's sort of pinkish. If you are wearing green, you are next to come up. Okay, that works. If you are wearing yellow, you're next. Okay, this is going to get a lot of people. If you're wearing blue, I think a lot of people will come up for blue. Put it on the one you think and then sit down so there's room for other people. And if you are wearing black or anybody else that hasn't gone up yet, go up now. Oh, yeah. Okay, everybody's voted? Okay, good job, guys. Put it on, then sit down. And I will tell you, okay, we'll see if we have any math whizzes here. I will tell you, choice D got a lot of votes. But, okay, it got 10 votes. B got 9 less. Can anybody figure out how many B got? 1. Raise your hand, Carson. 1. Okay, guys, let's do that on our fingers, okay? Everybody, put up 10 fingers. Okay, I said B got 9 less. Should we put up more fingers or take them down?
Take them down.
How many should we take down? How many? 9. Okay, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many are left? So the math problem was 10, take away 9 equals 1. I know you guys did some division last year, challenge problem. Add 1 to C and divide your answer by 6. You get A. Add 1 to C, divide your answer by 6, you get A. Brielle? 2. Excellent. I like to divide the students into 4 or 5 groups max. Then I assign jobs using the letters A, B, C, and D. I usually try to assign the A job to the best student to lead the group with the more difficult tasks. Kindergartners get index cards to remember their job letter. Remember? No more baby job cards. Okay, I'm only giving you once, so remember, don't say, Mr. G, I forgot what letter I am. I'm only telling you once. Here we go. Ready? Henry, A, B, C, D.
Yes.
Guys remember your jobs? Okay, here we go. Melora, A, B, C for Cooper, D. Okay, A's, get a film container. The kids love doing their individual jobs, feeling an essential part of the group. All the materials are set up in one area. The students retrieve one object at a time. You see here a first grade class having lots of fun mixing water and Alka-Seltzer together in a film container. But of course, I had to explain what film is, since no one had a clue. You guys can tell them when to stop, halfway. Okay, I'm gonna count to 3, guys, get ready. Everybody get close. Get close to your jobs. Ready? 1, 2, 3, put it on, snap it shut, shake it 3 times. Don't touch it. Whoa, whoa! Don't touch it. Whoa, whoa! Okay, sit down. 1, 2, 3, eyes on me.
1, 2, eyes on you.
You saw bubbles being made in the film container, right? Now these bubbles are filled with a gas, and they want to take up a lot of space. Is there a lot of space in your film container? No. Okay, so these bubbles, they start crowding each other, and they want to take up more and more space in there instead of pushing against each other harder and harder and harder. And finally, they're pushing so hard that what happens? Because of this pressure that builds up in that film container and shoots that thing up to the ceiling. And who knows how high it would go if we did it outside. That would be crazy. Now, guys, I told you that the bubbles were filled with a gas. Can anybody guess the name of that gas? Because I think you've heard of it. Sam?
Carbon dioxide.
He's right. Carbon dioxide. Okay? Now, here's the crazy thing, and this is why the experiment works. Is there any carbon dioxide in water? So we started out with water and Alka-Seltzer in there. There's no carbon dioxide in water. Was there carbon dioxide gas in the Alka-Seltzer? But when we mixed them together, it made that gas. So that is called a chemical
Reaction.
The whole process has been really fun for me and a great learning experience for the kids. I hope you enjoy the short video presentation of my program in action.
Hi, I'm Casey Cunningham. I teach 3rd grade at Aspen Elementary School. Anytime my students see Mr. G's name go up on the board, they are elated. He flawlessly goes through the scientific method with them, and his hands-on approach to teaching science is second to none.
Kids love science because of Mr. G.
I love doing science experiments with Mr. G.
I like it when Mr. G comes into the classroom because it's just always so much fun and I love his experiments.
Since kindergarten, I've always loved the experiences, my experiments with Mr. G. They've always been super cool, and the elephant toothpaste is my favorite. I like them because they can be scary, which I like, and very interesting and cool.
School without Mr. G would be less fun.